Good morning. You probably learned this algorithm in previous classes, previous courses. I'm going to repeat that anyway. So we will be talking about how to convert a number into a binary format, 8-bit binary format, with using loops or without using loops it's easier. It's not a rocket science, but we'll see how that conversion works. All right, so let's go here. Let's take unsigned char as 8 bits, right? And first, if it is so, you need to understand if a bit is 1 at the 7th position, what is the value is contributing to the number. So we are trying to understand first. Let's try to do from binary to decimal. First, let's try to understand that. Then we go reverse. Okay. Sounds like a fun, right? So this is the binary format, right? And we have 1 here, we have 1 in the 5th position and 1 in the 1st position. So if I were to ask you what is this decimal number, you probably figured this out, right? What is 2 power 7, which is 128, right? How did I get 128? 2 power 7. And in C language, that you can get that by 2 comma 7. So you have 128, and what is the value here is 0. We don't count it, right? And what is the value here, which is 1? What does it mean? It means it is 2 power 5, which is 32. That is 2 power 5. In C language, what do we do? Power 2 comma 5, right? So we add 32 to our, and here it's 0. So we ignore 0, ignore 0, ignore. We have 1 here. So it is 2 power 1, which is 2. So we add 2 to that. And this is 0, we ignore. So what is the value of this number we have given in binary, which is 162, right? Is it not? So now we know how to do any binary to decimal, right? So let's do the reverse now, from decimal to binary. So if I give you 168, right, and I want you to convert to binary, right? Remember the coin program that you guys wrote? You probably known. If I give you 92 cents and ask you to convert into nickels, dimes, quarters, and pennies, how do you do that? You pretty much would say 3/4, right? You went from the largest value. You didn't go with nickels or dimes, right? You didn't say you want 9 nickels or 9 dimes. You didn't do that. You said 3/4. Why is that? Same here too. It's identical. If I were to ask you, I give you 162, I want you to convert to binary, you would say, I would simply say 162, my largest value is 128, I'll deduct 128 first. Is it not? This is the number, and this is your the highest, the bit position that contributes to the highest is 128. So you will say 1. There 1 there, right? 1. and you deduct the remaining amount, just like the coins we did, right? So how much is that? 4 and 3, is it not? So you got the num, and your position initially was 7, and you got 128 by 2 power 7, right? Similarly, now let's go back, and I'm going to write this 1 somewhere else, okay? So this is, I'm going to put 1 there. So now we have, what is our position, current position? We are going to reduce that position by 6 now. And our algorithm says, if you go back and see the algorithm that we did, all right, algorithm is, if number greater than or equal to power 2 comma position, then we said print 1 number equal to number minus 2 comma position, right? This is what we did. Else print 0, right? Go back, pause the video, go back and see what we have done. There is no difference, right? So our num, if you go back to the next previous paint, our num is 34, position is 6. So let's go and understand this now here. So num is 34, position is 6. So num is 34 greater than 2 comma 6. 2 comma 6 is how much? 64. Is 34 greater than 64? No. So what do? Print 0, right? Print 0. Print 0. Right? Now go back. Go back to the, again go back. We reduce the position to 5 now, right? We reduced position by 1, is it not? Go and check the website, right? It's 5 now. Our number remained same. We didn't touch the number. You see that? Go back. 34 greater than equal to power 2 comma 5. 2 comma 5 is 32, right? Is 34 greater than power 2 comma 5? Yes. What do? Print 1. Let's go and print 1. That will make us easy. Print 1. Okay. Let's see what the next step in the algorithm is. Num equal to num, which is in our case 34 minus 32, which is 2. So our num became 2. Sorry. Num becomes 2. Our next iteration power becomes, position becomes 4, right? 4. Right? I'm going to erase all these guys. So it's to be a space. Right? So 2, next iteration. 2 greater than 2 comma 4. 2 comma 4 is how much? 16. Is 2 greater than or equal to 16? No. So what do? Print 0, right? So let's go and print 0. Right? Go back and Our position has to go back to, our position is should be less, right? Every time we reduce it by 1, 3. So now let's go back. 2. 2 greater than or equal to power 2 comma 3. 2 comma 3 is how much? 8, right? Power 2 comma 3 is 8. 2 is not greater than 8. What do we do? Print 0. Print 0. All right. Let's go back. And what happens when we do that, right? We're erasing it, and it's not, we're reducing it by 1. It should be 2. Go back again. Is 2 greater than or equal to power 2 comma 2? What is 2 comma 2? Power 2 comma 2, which is 4. 2 is not greater than 4. What do we do? Print 0, right? Print 0. Go back. What do we do next? Sorry. It's 1. So go back. 2 greater than or equal to power 2 comma 1. So 2 is greater than 2, is it not? Yes. So what do we do? Print 1. Print 1, right? So we need to go and print 1. Let's go and print 1. Right? So we're done with that. So we are done with that. And we have to reduce this guy to the next one, right? Just, oh, by the way, we need to update num, right? Num is 2 minus 2, right? Which is becomes 0 now. It becomes 0. When we print 1, right? We printed 1 here. Whenever we print 1, we need to deduct, right? So deduct num, which is 2 minus 2 power 1, which will become 0. Position becomes 0, right? Reduced by 1. Let's go back. Is 0 greater than or equal to power 2 comma 0? What is 2 power 0? It's 1. Is 0 greater than 1? No. What we do? We print 0. We print 0. And because we now we stop, because position is 0, we stop. If you see the algorithm I've given you, if it is 0, which is the last one, see here, there's nothing else to do. We stop. Now let's go and compare our program. So this is what we printed, and this is what we started off. Is both are same. 1 is 1 here, 0, it's 0 there, it's 1, it's 1 there, 0, 0, 0. So it's all matches. Then we got 1, it's 0 and 0. See, it's not rocket science at all. It's just not rocket science. Right? So we can quickly do one more example. And that way, but this time I'm going to go fast, right? Let's say 198. Is 198 greater than 128? Yes. So I'm going to print 1. So redirect 128. 0, 7, right? So 128 I got. What is the next number? 64. Is 70 greater than 64? Yes. Print 1. Detect 64. How much have I got? 6. What is the next number? 32. Is 6 greater than 32? No. Print 0. 16. Is 6 greater than 16? No. Print 0. Right? We got 8. Is 6 greater than 8? No. Print 0. What is the next number? It's 4. Is 6 greater than 4? Yes. What do we do? Print 1. Detect 4. We got 2. It's 2. Is 2 greater than or equal to 2? Yes. What do we do? Print 1. Right? Then 1. Right? And of course, when we print 1, we didn't detect 2, so it becomes 0. 0 is not greater than 1, so it becomes 0. So that is your binary conversion. Right? 128 plus 64, which is 192, plus 4, 196, plus 2 is 198. So that is the algorithm, okay? And try this out. And now you can use the for loop, while loop, any loop that you can do, right? Simple.